Dear children, in this video I am going to explain a pair of linear equations in two variables, which is chapter number 4 in 10th grade. Okay, first of all, we will revise a few basics. Okay, what is the standard form of the linear equation? Yes, hope you all recollected. It is ax plus b is equal to 0. This is with the one variable. See here, x is a variable. A and b are the coefficients which are belongs to the real numbers, complex numbers. Okay, and a should not be equal to 0. So this is the linear equation. Linear equation eppudu cheptamante when the variable have the power 1, it is said to be as a linear equation. And this linear equation used only one variable. So this is the linear equation in one variable. Suppose if we want to write a standard form for the linear equation in two variables. So what I can write, ax plus by plus c is equal to 0. Okay, here A, B, C belongs to real numbers, and A should not be equal to 0 as well. B should not be equal to 0. This is the linear equation in two variables. Here x is one variable, y is another variable. This is the standard form of linear equation in two variables. This is linear equation in one variable. Okay, now we have a business with this. Next. In the heading, if we observe pair of linear equation in two variables. Pair means we need two equations. So let us consider a1x b1y c1 is equal to 0, one equation. Another one is a2x plus b2y plus c2 is equal to 0. Another equation. Okay, here a1, b1, c1, a2, b2, c2 are the coefficients of the coefficients, and they belongs to real numbers, and x and y are the two variables. One more point we need to remember, when we draw the graph for these linear equations, we always get a straight line. Okay, a straight line. It's a straight line. Next, another thing, if the lines have at least one solution, suppose two lines we are putting on the graph. If the lines have at least one solution, they are called as consistent lines. Consistent. If the lines doesn't have any solution, we call them as inconsistent. Inconsistent lines. Coming deeply for learning about pair of linear equations in two variables. So I'll give a easy mind map to remember. Pair of linear equations. There are two types. One is consistent. Another is inconsistent. Just now I said consistent means having a solution. If the lines have at least one solution, they are called consistent. Inconsistent means having no solution. They doesn't have any solution. Inconsistent lines. I said having solution. Suppose if you have a unique solution, one solution. Unique solution of the variables x and y, then the lines are intersecting lines. Then the lines we get intersecting lines. Intersecting lines means like this. They meet at some one point. Okay, suppose two lines are there, L and M. They meet at one point. So these are intersecting lines. Suppose if they have infinitely many solutions, infinite solution, infinite solutions, then these are coincident lines. Coincident lines. Coincident lines means suppose one line and one line ke upar another line. We will get in this way. L and M. Okay. If the lines are intersecting, then the condition for this is A1 by A2 is not equal to B1 by B2. What are these A1 and A1, A2, B1, B2? We just learned from this standard form, right? They are the coefficients of X and Y variables. So these things. The condition is A1 by A2 not equal to B1 by B2. If the lines are coincident, lying on one on each other, then the condition is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Three of them will be equal. If they're intersecting lines, they are independent. The variables are independent to each other. Independent to each other. Okay, X and Y are independent to each other since they have only one solution. Here, if the lines are coincident, they are dependent on each other. X and Y values are dependent on each other. Suppose for one value of a X, you will get another value of a Y. If you change the X value, appropriate Y value you will get since it is having infinitely many solutions. Now coming to the inconsistent part. Inconsistent means no solution. Then how about the lines in this? When we draw the graph, the lines are parallel. We will get parallel lines. Parallel lines means they will not touch anywhere. They won't have any common point. You cannot draw out any solutions from this. And the condition for this is A1 by A2 is equal to B1 by B2 and it is not equal to C1 by C2. And there is no question of dependent and independent because here you are not able to find out any solution for X and Y. So there is no question of dependent or independent. I repeat, pair of linear equations lo consistent and inconsistent ani two types of linear equations untai. How you can decide means solution is there means it is consistent. Solution is not there, then inconsistent lines. Consistent lo two types, unique solution or infinite solution. If you are getting unique solution, then the lines are intersecting in this form. Okay, if you draw the graph, you will get like this, similar to this. Infinite solutions and coincident lines anmata. They will lie on each other. Okay. So the conditions to identify those type of lines is A1 by A2 is not equal to B1 by B2. It should not equal to lo. It is touching, right? Intersecting. These three lines are intersecting. So you can remember this condition easily. Not only that, here X and Y you are getting values. Those are independent to each other. Okay. X and Y values are independent. Next, coming to here, infinite many solutions, right? The condition is A1 by A2 equal to B1 by B2 equal to C1 by C2. So according to the A value and B, according to this, if X value changed Y value, you will get a different. The X value is taken, chosen another means Y also will get appropriate value. So they both are dependent each other. Depending upon the X, you can draw out the Y value. Next, coming to the inconsistent lines, here there is no solution at all. So the lines will be like a parallel lines. They will not connect anywhere. And the condition is A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. Now let's solve the first question. By comparing the ratios A1 by A2, B1 by B2, C1 by C2, state whether the lines represented the following pair of linear equations intersect at a point are parallel or coincident. First one on my board. Question number 1. 5x minus 4y plus 8 is equal to 0. Next one, 7x plus 6y minus 9 equal to 0. So, by observing these two lines, we have to decide whether they are intersecting, parallel or coincident. So, for doing that, we need to check with their conditions. Let's compare with the standard form. So, what is our standard form? A1x plus b1y plus c1 equal to 0. Another one, a2x plus b2y plus c2 equal to 0. So in this we can, a1 is equal to, if you compare, a1 is equal to 5, b1 is equal to, take along with the sign because these are all positive, right? Minus 4, c1 is equal to 8. Coming here, a2 is equal to 7, b2 is equal to 6, and c2 is equal to minus 9. Okay, let's see what type of lines they are. First, we will find out a1 by a2 value. 5 by 7. No simplification can be done here, right? Now let's find out b1 by b2 value. Minus 4 by 6. Here they have a common factor 2. 2 2 is 4, 2 3 is 6. So answer is minus 2 by 3. Now we will find out c1 by c2. 8 by minus 9. Here also you can't simplify further. So a1 by a2 is not equal to b1 by b2. These both are not equal. So when we got this both are not equal, there is no need to check c1 by c2. Here we can observe that when we get this cutting lines, they are intersecting at two different points, right? So intersecting lines you can remember easily. When not equal to, symbol is a seen. Lines are intersecting. If the lines are intersecting means intersecting. Intersecting means you can give only one solution, right? One solution can be obtained. Next. Next, B bit. 9x plus 3y plus 12 is equal to 0. 18x plus 6y plus 24 equal to 0. So here a1 by a2 is equal to 9 by 18, which is nothing but 9 ones are 9 twos are. b1 by b2 is equal to 3 by 6. That is nothing but 1 by 2. Next, C1 by C2 is equal to 12 by 24. This is also 1 by 2. So let's compare first A1 by A2 and B1 by B2. 1 by 2, 1 by 2. So they both are equal. If they both are equal means you need to check the other C1 by C2 also. Of course, this is also equal. C1 by C2. When these two are equal, we can say that the lines are coincident lines. Okay, they will lie on each other, right? Coincident lines. Lines are coincident. And they will have infinitely many solutions. Okay. The last one. Third one. C bit. 6x minus 3y plus 10 equal to 0. Another line, 2x minus y plus 9 equal to 0. Let's compare. A1 by A2 is equal to 6 by 2. That means 3 by 1, right? Next, B1 by B2 is equal to minus 3 by y coefficient is minus 1. Minus minus cancel, 3 by 1 again. Next, C1 by C2 equal to C is 10 and by 9. Nothing has a common factor. So here we can conclude A1 by A2 is the same as B1 by B2, but this is not equal to the C1 by C2. So in this case, when one is equal, one is not equal, lines are parallel. Lines are parallel. And there is no solution for these lines. No solution. Thank you.